Alright, now it's time to talk about horizontal projectiles. Now, horizontal projectiles in general follow a nice parabolic path. Things we know about horizontal projectiles. Velocity in the x direction is relatively constant. So the velocity up there, the horizontal velocity here, and the horizontal velocity at this point, Vx, these would all be the same. One thing that is not constant, and that is the vertical velocity, Vy here, compared to Vy here, compared to what it would be here, clear off the page, Vy there is not at all the same because you've got gravity acting on it. Now, velocity in the x direction is constant because there's nothing else going on right there. You've only got the velocity from the cannon or whatever it might be. However, in the y direction, v final y, you might say, is under the influence of gravity. If it falls for a certain time, it will have a certain speed. V final y squared equals V initial y squared plus 2g delta y. Now, check this out. When we talk about our horizontal projectiles, we're considering Vy to be 0. Therefore, if I fall for a certain distance, I will gain a certain speed. Just like if I fall for a certain time, I will gain a certain speed. Now, this is all vertical velocity. Okay, that's all directed like that, downwards. Not a horizontal velocity, that's directed entirely sideways, and that doesn't change one bit throughout the whole process. Now let's talk about a more specific example, perhaps. Okay, here now we have a cliff. At the top of the cliff, there is a cannon. And of course, we have our friend Wile E. Coyote at the top of the cliff. And what does Wile E. Coyote want to do? Wile E. Coyote wants to hit our poor dear friend the Roadrunner. Now, you're asking yourself, how can I solve a problem like this? Well, you need some information first. Let's say that in this problem, the cliff is 176 meters tall. 176.6 meters tall. And let's say for this particular problem that our cannon that Wile E. Coyote is firing is going to travel with a muzzle velocity of 110 meters per second. We want to know, when Wile E. is planning this out, where should he put his little birdseed trap that he always tries to use on a Roadrunner? What delta x should we use? Well, what we know is we know delta y, we know velocity x. That's our question mark. Well, the path that the projectile will follow has something in common. Delta y and delta x operate in the same time. And so if we use the equation, delta y equals 1/2 of g times t squared, and we use the height to find the time, we can then take the time equals velocity x times time. We can use that time with the velocity to locate the displacement. So most horizontal projectile questions work out in this manner, where you're either given the vertical height, asked to find time, and then use time with one of these two characters to find the other of the two characters. Let's do a couple quick calculations here. If I put 176.6 in, and I get my calculator out here, and I say on my calculator 176 6.6, and I divide by half of g, because I'm going to have to move my half of g over by dividing. 176.6 divided by 4.905, both of those numbers being negative, and I get a nice and convenient 36 square seconds equals delta t squared. And then we can see that this is squared. We must square root both sides. The time equals 6 seconds. As I said, plug that into this equation with the velocity given up here. And I say that delta x equals 110 meters per second times the 6 seconds. Multiply that out, 660 meters out. That's a vast majority of what you're going to do in these kind of problems. The key to horizontal projectiles is time. Because velocity x and velocity y are, all right, ready for it? Big idea. Independent, because they are independent. They're independent, but they happen at the same time. Okay? It's like fall. Fall is a season where there is the corn harvest and there is football. They're independent of one another, but they happen at the same time. Well, it goes sideways. It falls independently, but they happen at the same time. That's how you do these problems.